Namaste students, हमेशा खुश रहो बिटिया. I am JV'n's Dr. Neeraj Dholia, Faculty of Agriculture and Veterinary Science, Jayoti Vidhyapeeth Women's University, Jaipur. So today we are going to discuss the topic liquid extraction or LLE. It comes under the subject upstream and downstream process. So let's start. So the liquid extraction or the solvent extraction. It is also known as the solvent extraction because here we use these solvents, various solvents, to extract some compounds or specific compounds. So basically, it is a method to separate compounds based on their relative solubility in two different immiscible liquids. Immiscible means which are not uh, mixed, can two solvents or two liquids which cannot be mixed. For example, the water and the oil. So if we mix both of them, they are immiscible. They will not solubilize each other. Okay, so that is the immiscible liquids. So it is a method to separate compounds based on their relative solubility in two different immiscible liquids, usually water and an organic solvent. Okay, so we use here various solvents to extract out specific compounds. Depends on the solubility of the compound. So it consists of transferring one or more solute contained in a feed solution to another immiscible solvent. So here we extract compounds, and the compound is already present in a solution that is known as the feed solution. Feed solution means the solution which carry your compound, and we use another solution uh, which is used to extract out these compounds from the feed solution. So here a liquid carrier containing the compounds to be recovered is fed into an extractor where it contacts a solvent, and the two liquids must be miscible, which allows them to form a dispersion with one liquid dispersion as droplets in the another. So uh, feed solution is used, and another solution is used that is known as the extractor. Generally it is an organic solvent, like ethanol, methanol, acetone, etc. So they are known as the extractor solutions, extractor solvents. Okay, so they used to extract out some compounds, and because the feed solution and the extractor are not they are immiscible, so they're not mix up, and they form the droplets in each other. So it is a separation process. It is based on the different distribution of the compounds to be separated between two liquid phases. So it depends on the mass transfer of the component to be extracted from first liquid phase to a second one. Okay, it is understood. So this method is very useful where distillation fails. Means, for example, if some compounds are temperature sensitive, you cannot boil them, then you cannot use the distillation to extract out the compound. So in this type of situation, the liquid extraction is very important, because in this method we do not boil the samples, or we not raise the temperature. So the various extraction methods are there, namely the Coulter, Sattler, hydrocyclone, centrifugal extractor, flotation, liquid phase adsorption, and column extractor. So these are the name of the various extraction methods of the liquid extraction. So equipment used is extractions can be carried out batch wise. For example, mixtures in a continuous mode, either example mixture settler or counter currently operate columns. So borosilicate glasses are generally used is ideal material for extraction equipment, as the process can be optimized while visually observing the process. Okay, so you need to observe the reaction between process. So we generally use the glass vessels. The borosilicate glass materials are used so that you can visualize the things, and you can adjust the things. The batch method is using the mixtures and reactors. So using the mixtures in a batch model offers a huge flexibility to optimize them mass transfer by varying ratio of liquid phase and type of stirring in the glass. While using the glass materials or the glass containers, you can optimize the stirring mixing time, etc. The settling period can also be easily influenced by varying the time. Okay, so these are the variants which can be adjusted or can be changed according to the conditions. So batch operation is labor intensive and requires sufficient big equipment. It is can be operated at laboratory scale also. So using the comparatively small equipments. Okay. So this is especially advantage for the extraction of reaction mixtures, as it can be carried out in the same equipment as the reaction. So mixing can be adjusted by the stirring shape, speed, and mixing time. So these are the variants. You can change the phase separation in a question of time and can be observed advantageously in a glass reactor. So you have to wait till the phase separation, and it is easy to use the glass equipments because you can visualize the phase separation here. So for the phase separation, it is necessary to determine the location of the interface, and in the reaction, this can be measured by system based on a floater or a radar signal. So these are the things which can tell you that the interface is established. So use the floater, radar signal, and conductivity depending on the system to be examined. So outside the reactor, it is also possible to detect the interface while draining the lower means of interface, while draining the lower means a heavier phase through the bottom outlet of the visual inspection through a glass pipe or by a sudden change in the media property. So creating the interface or separating the materials after the reaction time over, the heavier phase which is at the bottom side can be separated out by the uh, bottom outlet, and it is easy to, if it is a glass vessel, visually uh, uh, you can remove the bottom outlet, and when the bottom outlet is removed, you can stop the outlet or of the outlet. So this is the process of separating the material. So hope you are satisfied with this detailed session, and if you have any query, please write in the comment box. I will resolve your query. This session is powered by Digital Version 2, Jyoti Vidhyapeeth University, Jaipur. Thank you.